Greetings. So we're done with chapter 4 and moving on to chapter 5. You'll notice in the top corner here it says geometry, and chapter 5 is going to be largely associated with some information that may be unfamiliar. And the goal here with the inquiry labs, we're going to do 2 of them this week. The goal is to solidify your background knowledge that some of you may not have, and hopefully if you do have some of this background knowledge, access what you do know and be able to move forward. So today, here's what we're looking at. What are the angle relationships formed when a third line intersects 2 parallel lines? So we're looking at this diagram right here. It says a newspaper route has 2 parallel streets. The streets are cut by another street as shown in the figure. So Main Street and Columbus Way are parallel, and Broadway Avenue is intersecting both of those streets. And what we're going to see is that there are certain relationships, as it says, between the angles that are formed here. Okay, and that's what we're going to be looking at. So this is just a visual picture to kind of get your brain moving a little bit. And what you're going to see is that this line and this line are intersected by this line. And what's going to happen is you're going to have, if you look at it from a standpoint of intersections, you have 4 angles here, and you have 4 angles here, for a total of 8. So if you look down to the beginning of the investigation, parallel lines have special angle relationships. You will examine those relationships in this investigation. So let's have a look. Step 1, use a protractor and angle relationships you have previously learned to find the measure of each numbered angle and record it in the table. So what I would like you to do is take your protractor or angle wheel that you've been given, and let's start by measuring angle 1. So just to remind you what it looks like if you have a protractor with you, just kind of some again background knowledge and use of a protractor. What you're going to want to do is put the hole or the 0 right here on the vertex of the angle. And you want to make sure that protractor looks like this. So when you're laying it flat across this angle, and the half circle side should be going this way. If it's a whole circle, then obviously the whole thing is going to be around like this. And what you're looking for then is, generally speaking, what should happen is 90 degrees should be right there, which would indicate that if I'm measuring angle 1, it should be greater than 90 degrees. And what you do is, if you need to, take the edge of your protractor and kind of extend this line of this ray right here so that it goes as far as you need it to go through the protractor. So take a minute and measure that angle, and pause the video now, come back to it when you have a measurement. So what you should have found then is that the measure of angle 1, which is this angle right there, is somewhere in the neighborhood of 115 degrees. So if you got somewhere close, great. If you got 115, even better. For the intents and purposes of this activity, we're going to use 115 degrees for reference. So we're going to go ahead and write 115 degrees in here, like so. Alright, so then angle relationships. There are a couple of different angle relationships that you should recall from past lessons. The first of which that we're going to be using quite a bit in chapter 5 is called supplementary. And you'll recall that supplementary angles are, first of all, a pair of angles, so 2 angles, that add up to 180 degrees. So if I take a line, like a number line or any line really, we'll just use this guy for right now. If I take a line and I break it into 2 pieces, I take it here in the middle. First of all, a straight line is also known as a straight angle. This is 180 degrees, right? We've learned that before. Not us, we, as in you and me, but you have learned that before, somewhere in your history of math, probably last year in 7th grade. At any rate, if I draw I can draw this angle anywhere. It doesn't matter which way it goes. I can do it really, really small that way. I can do it kind of close to 90. I can do it exactly 90. I can do it anywhere in between. So that being said, let's kind of give these angles some names here so that it has some context. We'll just for right now call it angle 1 and angle 2. I don't believe I have an angle sign, so I'm just going to say angle 1. So we'll call the obtuse angle angle 1. Remember, obtuse is greater than 90 degrees. You can tell it's greater than 90 because it's bigger than the straight ahead. And then we'll call angle 2 the other side of that. And then, so what's going to happen, obviously, is that angle 1 plus angle 2 should equal 180 degrees, right? This angle plus this angle equals 180. So, that being said, up here, the exact same thing is true. 1 and 2 are supplementary. So, there's my straight angle right there. Angle 1 goes off in this direction this way. So, if angle 1 is 115, that means that angle 2 should be 180 minus 115, which would give me 65 degrees. So we're going to go ahead and write that in for angle 2, 65. And it might take me a second to find the, oh, look at that, first guess, 65 degrees for angle 2. Okay, let me kind of erase what I have here. You really don't need to measure anything else with the protractor, so you can put the protractor on the side for a second. And then what we're going to do is just use some, what it says, angle relationships, and you've previously learned. So really what we're going to focus on here is the idea behind supplementary angles. So we're not going to do any measuring for right now anymore. Let me erase what I have here so far so that you can kind of get a better look at the parallel lines. Okay, and then what we're going to do is we're going to take this guy away. Maybe. Oh, there we go. Take him away. So this line and this line are parallel. This line is intersecting. We'll get to some terminology later. This line is called a transversal. You may have heard that before. So now I have some information down here. Angle 1 is 115 degrees and angle 2 is 65 degrees. Alright, well, let's look at this way in terms of, now that I know what both of those angles are, you're going to be able to make some, or draw some conclusions rather, again, based on information that you know. So now let's consider if you can ignore this line right here, pretend this line is not here, and just look at this and this. Okay, you can dig that. So here's what's going to happen. Again, I have this straight line, which basically is a straight angle, okay, and that would indicate that if I break this into two pieces, angle 1 and angle 3 should also be supplementary. Wouldn't you agree? So that would mean that, again, the measure of angle 3 should be 180 degrees minus 115, which would again be 65 degrees. So angle 3 is also going to be 65 degrees. So far so good. And then I could also reasonably conclude, let's see if this makes sense to you. Move this guy out of the way and let me pivot him around like that and bring him down here. Now that I know what angle 3 is, see how close I was. Not bad. Alright, so now that I know what angle 3 is, now I can use this and that to concentrate on angles 3 and 4. Alright, you're visualizing this. Angle 3 is 65 degrees. Well, angle 3 and 4 are supplementary. You could actually do it with 2 and 4 also, but for right now we're doing it with 3 and 4. 3 and 4 are supplementary, which means if 3 is 65 degrees, then 4 should be 115 because it's 180 minus 65. I don't like the way that looks. I'm going to go ahead and just redo all of those as 115. So I got 115 for angle 1. And then right now I have 115 for angle 4. So now I know the measure of all four of these. Now, again, you could draw some conclusions based on things that we haven't learned yet also. For the time being, we'll go ahead and measure angle 5 really quick, and we'll go on from there. And I'll give you a hint. It should look very similar to angle 1. So pause the video now, measure angle 5, and come back with your results with your protractor. So what you should have determined based on measuring angle 5 is it looks an awful lot like angle 1, which would indicate that it would also be 115 degrees. So again, you can draw some conclusions based on the rest of these. If angle 5 is 115, which it is, hopefully you filled that in already. If angle 5 is 115, 5 and 6 are supplementary, aren't they? Which means that 6 should be 65. Okay, let me get rid of this now so that you can see all the lines a little bit more clearly. If 6 is 65, well, 6 and 8 are supplementary. You can see that. There's the line that has both 6 and 8 on it. There's the line that breaks them into two pieces. So if angle 6 is 65, then angle 8 should be 180 minus 65, which again would give me 115. And then if I know the measure of angle 8, actually I could do it from angle 5 as well. It really makes no difference. 5 and 8 are both 115, right? They're both supplementary to angle 7. Here's this line. So then breaking 7 and 5 into two pieces right there. Or if I use this line and break 7 and 8 like that, no, it doesn't really matter. 8 is 115 or 5 is 115. That means that 7 should be 65 based on just supplementary angles again. So now I've filled in my table here, just simply based on the concept of supplementary angles. That any two angles broken by a straight angle equal 180 degrees. So it says color the angles that have the same measure. I mean, you have colored pencils, so go ahead and do that. Here's all you're going to do then is with your colors. You should only have two different colors, right? Because half of the angles are 115 and half of the angles are 65. Now, I originally wanted you to do that by yourself and give you a second to do it, but I think it's more important that I introduce some geometry symbols that you're going to see throughout the course of this chapter and really the rest of your life as a student, as a math student. So I'm sure you've seen this before, just to kind of tell you what it is. So anytime you see an arc like that representing an angle, okay, what this means is that this angle has a certain measurement that is generally associated with one or more other angles. And what's going to happen is, so if you're following these directions, color the angles. Alright, so take one pencil and do the following. Make this mark over angle 1. And then what we're going to do is take a look at the table and see, so angle 1 is 115 degrees, so is angle 4, so is angle 5, and so is angle 8. So we're going to make this symbol with the same color over all of those angles. So I'm going to have it over angle 1, angle 4 is going to look like that, angle 5 is going to look like that, and angle 8 is going to look like that. And that is traditionally how you represent angles that are congruent in geometry. Now, when you take your second color, I would recommend, so you notice that we made one curve. When you take your second color, not only are you going to make the curve with all these congruent angles, so now 65 degrees for number 2, number 3, number 6, and number 7, but I'm also going to make 2 of these curved marks, which just makes it easier to see. So 2 is congruent to 3, which is congruent to 6. It's getting a little tight here, which is congruent to 7. And those again are just standard symbols that you're going to see in geometry, indicating that all the red single curved angles are congruent and all the purple double curved angles are congruent. It's very easy to look at the diagram and decide what's going on there. So, describe the position of the angles with the same measure. Describe the position of the angles with the same measure. So, this is kind of an introduction to something else as well. If you look at it, the angles that are purple, okay, these two angles are kind of like across from each other, like that. 6 and 7 are across from each other. But now you'll see something interesting also. 2 and 6 are congruent to each other. They are in a certain relationship in a certain location, which we'll get to later. 3 and 7 are in a certain relationship. So for all intents and purposes of this question, I think we're going to focus mainly on the fact that these angles that are across from each other, 2 and 3, 6 and 7, and the red ones, 1 and 4 are across from each other here. 5 and 8 are across from each other here. So angles that are across from each other are congruent. And you may or may not have background with that. But these angles are called vertical angles, and we'll get to that somewhere down the line. Replay any of that if you need to, otherwise we're moving on to the next part. Okay, work with a partner. I'm your partner. Congratulations. If the measure of angle 1 in the figure at the right is 40 degrees, determine the measure of each given angle without using a protractor. Okay, so now on the previous example, I had to measure one of the angles. On this page, they're giving me the measure of one of the angles. So believe it or not, when you have parallel lines in a transversal, all you need is one angle measurement, and you can find the other 7. All you need is one. Okay, and again, if you need to look back to see why that's true, please do that. Otherwise, we're going to kind of forge ahead here. So they're telling us that angle 1 is 40 degrees. The most important thing that you can do off the bat anytime in geometry is label any information that they give you. So that means this angle here is 40 degrees. So based on that, what conclusions can you draw? Okay, well, if you remember what the symbols looked like, the angles that were across from each other, 1 and 3, are congruent, called vertical angles. So angle 3 is also going to be 40 degrees. So I'm going to go ahead and fill that in. One and 2 are supplementary, which means angle 2 should be 180 minus 40, which is 140. Angle 4 is also supplementary to angle 1. It's also opposite angle 2, so it's 140 degrees no matter how you look at it. Either it's congruent with 2 or it's supplementary to 40. Alright, so you remember that we said, based on the other example, angle 1 was a certain measure, angle 5 was exactly the same, because if these two lines are parallel, and we'll get to this again, these are called corresponding angles, and what that means is that they are in the same location, which in this case, this is the upper left-hand corner, and this is the upper left-hand corner. We'll get to that in more detail later. It may not make sense right now, but based on that, 1 and 5 are the same measurement, so 5 is also going to be 40 degrees, and 7 is also going to be 40 degrees. Based on the fact that it is vertical to angle 5. Okay? So, as long as you know that, you are able to find the other two. Angle 6, based on the fact that it's supplementary to angle 5, should be 140. And angle 8, based on the fact that it is either vertical to angle 6 or supplementary to angle 5, is also 140 degrees. And there you have it. If you need to review that, go ahead. Otherwise, we're moving on. What is the relationship between the two horizontal lines? Okay, so this line and this line, what's the relationship between those two lines? Well, they're extending. Does it look like they're ever going to touch? I don't think so, which means that they're going to be parallel. So the relationship between the two horizontal lines is that they are parallel. Kind of gave it away by saying that they're both horizontal. Hopefully, that did give it away. What do you notice about the measures of angles that are side by side? In other words, next to each other. 1 and 2, 1 and 4, 2 and 3, 3 and 4, 5 and 6, 5 and 8, 6 and 7, 7 and 8. Angles that are next to each other. Those angles are supplementary, okay? Which means that their sum is 180 degrees. And for now, we might as well use the terminology that we're familiar with. They are supplementary. That will be good enough. I know that if you use the word supplementary that you know that the two angles add up to 180. So, congruent angles are angles that have the same measure. Describe the position of the congruent angles. We kind of talked about that on the previous page. So the congruent angles are opposite each other, like this, or like that. 2 and 4 are congruent, so they're opposite each other. 6 and 8 are also. And then we'll get to the corresponding part later. But again, just for all intents and purposes here, we're going to say that congruent angles are opposite each other. I think it's also important to mention that they share a vertex. So the congruent angles are opposite each other. That's all we need to know for that one. Good to go? Alright, so we go to the final part of it here. This is toward the bottom of your page. I had to make it 3 pages. It's only 2 for you. Draw a set of parallel lines cut by another line. Estimate the measure of the 8 angles formed. Check your estimates by measuring. We're not going to do the measuring part. Here's what we are going to do. We're going to draw the lines. So take your pencil. Does not have to be perfection here. Mine is going to be, straight, but yours certainly doesn't have to be. Here's what I'm going to do. We haven't seen vertical lines yet, so I'm going to make 2 vertical lines, and then I'm going to cut that with a transversal that looks like this. Okay, just for kind of a different appearance. What are the angle relationships formed when a third line intersects 2 parallel lines? Okay, angle relationships. Well, you basically have how many angles? 1, 2, 3, 4, 5, 6, 7, 8. 8 total angles, right? Which means 4 pairs. So you have 4, these two. Here, let me make the markings like we're supposed to. These two are congruent, correct, and these two are congruent, which means they're also all congruent to each other. Alright, so you have 4 congruent angles, which are also supplementary. And then you have, let me change my color so it makes a little bit more sense here. This and this is congruent. And also this and this is congruent. So the black angles are all congruent to each other, the red angles are all congruent to each other. The red and black are also supplementary to each other. So if we want to say something about it that way, what are the angle relationships? Well, when you basically end up with 4 congruent angles, 2 sets of 4 really, because you have 1, 2, 3, 4 black angles and 1, 2, 3, 4 red angles. So technically it's 4 of each. Two sets of 4. 1, 2, 3. 2 sets of 4. Two sets of 4 congruent angles. And that's kind of where we'll leave it for now, is those angle relationships. The black angles are congruent, all congruent to each other. The red angles are all congruent to each other. And we already talked about the supplementary side of things, so I don't really think we need to say a whole lot more about that. So, if you're really dying to measure those with a protractor and get some last use out of the protractor, go ahead and be my guest. But I'm pretty sure that we accomplished all that I wanted to accomplish with this inquiry lab, which will definitely lead you into lesson 1 tomorrow with enough background knowledge to be able to have some success. And I'll close with this. We have basically focused the majority of our time so far on algebra. Geometry is its own monster, so to speak, and what I mean by that is 2 things. geometry has some algebraic concepts associated with it, but it's also its own, its own subject of math, subtopic of math. So what you'll find sometimes is that if you did not have a lot of success with algebra, maybe you have more success with geometry. Typically, that's what happens with students who really struggle with algebra. Like chapter after chapter, algebra is just really not making sense. Geometry then tends to be the time where the light goes on, and that makes a little bit more sense, especially if you're a visual learner, because a lot of geometry is very visual, very eye-oriented, and so you'll find a lot more success with that. The other side of the coin, of course, then is it is different. It is involving different parts of your brain. That is very factually based. In other words, we're not going to study proofs, but there is definitely a why behind every what in terms of geometry, and you do need to be prepared to give more explanations. So I will send you off with that warning. But that's all for today. I appreciate your attention, and hopefully this was at a good speed and met your needs for today. So anything you need to go back and review, please feel free to do that. Otherwise, that is it for today. Have a great day.